The automotive products are clearly the most demanding products that we make. And the requirements that are coming from our customers, both in terms of quality and in the in-use properties, has been what's driven our focus on R&D. So both our laboratories existing in North America and those in Europe are very, very heavily focused, not only in providing new products, but also in new solutions for our automotive customers.
Cars have to get lighter, and in order to do that, we have to come up with new steels and new steel solutions that can achieve the levels of weight reduction we know we need to get our cars to their 2025 fuel economy standards.
What we do in automotive product applications is we're the first point of technical contact for our customers in the automotive industry. We work a lot with the folks that are actually kind of designing vehicles. What we do is find ways in which we can use some of the newest steel products that we develop and incorporate them into various part designs that the automotive engineers can work on.
It's very important that we work with the OEMs in a very close manner, because they start looking at the steels that they need 4 to 5 years ahead of the model launch. So we need to be ready with the steels and the properties that they will be requiring, and we also need to work with them in terms of how they will use these steels in their design. And today we are developing steels that will be used in vehicles that will be launched 3 years from now. This can only be achieved if you have very close working relationships with the OEMs.
And it's a very kind of collaborative effort. In addition to this, we also help them make sure that every part that we help them design or any new idea that we come up with are parts that actually can be manufactured. So there are a lot of computer-based simulations to ensure that the parts can be stamped well.
We know now much more what challenges our customers face on a day-to-day basis. That allows us to speak their language and understand their problems a lot more, providing them with solutions that directly impact their day-to-day problems and challenges. That has been very, very important in maintaining a technology leadership position in the automotive steel industry.
EVI is the early vendor involvement group, and their goal is to make sure that when a vehicle goes into mass production, that they don't encounter any major issues with our material. By using the circle grid analysis and thinning analysis, they're able to predict in full production mode when the tools are starting to wear that failure is likely. They have a lot of experience on the shop floor and also with the material.
We've done extensive work on automobile body design. We have now in our research centers all over the world the same kinds of FEA computer tools that automakers use to design their cars. Not that we want to take over car design, that's always going to be the responsibility of the OEMs, but by investing in the technology of body design, we've learned what each component needs to be as light and safe and fuel efficient as possible. And that knowledge has been turned back into our product development process.
Probably the most important claim to fame that steel has is that we deliver safety, we deliver weight reduction, we deliver ecological compliance at the lowest cost possible. Any other solution to reduce weight other than steel currently being exercised or looked at or attempted is significantly higher cost than steel.
The safety requirements have always been kind of going up increasingly. The objective is to have people walk away from any kind of accidents with as little injury as possible. And this requires for the steels to perform at a much higher level, be able to absorb a lot of the energy that is there in any kind of a crash event. So we are able to simulate all these real-life crash events to a really high level of fidelity with our computer models, to the point that the amount of testing that the automotive companies need to do prior to releasing their vehicle models is drastically kind of reduced. We model the entire car structure, and what the simulation, what it really does is ram a vehicle that's going at 25 or 40 miles an hour into a concrete barrier. And as you would see in real-life test videos, parts that are crushing, things that are breaking off, those are the level of details that a simulation kind of actually captures. We look for how the various parts are deforming, how the parts are bending or twisting or breaking or out of shape. Every part in a vehicle has a certain kind of role to play, and we look for whether it's playing that role the way it's kind of intended to. If not, we use engineering principles to make changes to the design so that they do what they're supposed to. Okay, so the question is, what can be done in that location? If you're able to change the section such that it's a little bit stiffer, so it requires a slightly higher force and energy management to get that crush, and that might be feasible.
The most important thing of any leadership in any organization is to open up and create an environment in which this creativity manifests itself. Because without this creativity, you will not be able to remain competitive.
If you look around East Chicago, you'll find at least 25 different nationalities. What this does is allows us to bring in a lot of different cultures, a lot of different ways of thinking, all of which can be used synergistically to rapidly, quickly develop and implement new technology.
It brings a new challenge to the entire technical aspect of the work. And of course, technical challenges is something that kind of draws a set of talent and makes people kind of enjoy the work.
At the end of the day, will all be played in the field of technology differentiation. And technology differentiation will be based on the ability of one company, one nation to outcreate another.